Good morning. Good morning. And today's STA's Expedition 32 International Space Station Program and Science Overview Briefing. With us today we have Michael Saffredini, the International Space Station Program Manager, Dina Cantella, the International Space Station Expedition 32 Lead Flight Director, and Tara Rutley, the Associate International Space Station Program Scientist. We'll start off with opening comments from all three, and then we'll move on to your questions. Mike?
Well, good morning. Good morning. We haven't spoken in quite a while. How we're doing, and one of my favorite topics now. Tara's going to spend some time with you about the research we're doing on board ISS. Since that's the focus, with assembly essentially being complete on board ISS. As everyone knows, we moved our launch dates a little to the right due to a pressure test problem that occurred while testing Vehicle 704. That's been taken care of. We've moved up the other vehicles that were following behind that one, and resulted in about a month and a half slip in our flights. And so that's the team's preparation effort is towards April 30th return of the crew on board and the launch of the next crew in the middle of April. However, there are a number of things that have to occur on orbit in sequence for things to work. And it's not just about crew rotations, it's also about the logistics on board, and then doing all the work that we need to do on board in between the arrival and departures of vehicles. So the crew on orbit today is, in the last few weeks actually, has been averaging on the order of about 50 hours a week, and this was our effort to catch back up with the crew time necessary to meet our requirement for the research community of 35 hours a week dedicated to research. And so we're well on track to reach that average in spite of the progress anomaly that happened earlier or about the middle of last year. It's hard, things are all going together for us. And so that's we're well on our way to catch back up. That was our plan at the end of this increment to be there, and I think hours-wise we'll be in good shape. So we're proceeding along well on orbit. We've had a couple of minor anomalies along the way. One of them, perhaps not so minor, but not causing us any problem on board today, is a main bus switching unit, MBSU. It's one of four very large power systems on board the ISS that distribute all the power from the solar rays to all the systems on board ISS. MBSU-1 has had a little trouble because of some radiation hits that were taken on its memory unit that it wasn't able to reset itself. And so in this particular condition now, the box has gotten to the point where it won't communicate with us, but it's still passing on power, and we have all the protections we require from it. So we've left it to operate alone, and it seems to be doing the function that's required. So assuming it doesn't fail in a manner that causes it not to provide power any longer, which we're not expecting, we are looking to replace that box in the late summer, early fall time frame, and I'll touch on that in just a minute as we go down the sequence of events. So that's probably the main one we've been working on. A little anomalies have occurred here and there. You've seen that the water processor was down for a little while. We had to replace a catalytic reactor in that unit. It's back up and running now. We've had a little hiccup with the one of the beta gimbals, the 2A beta gimbal, that we've recovered as well. It had some comm problems as well, which we think might be related to some FOD inside the beta gimbal unit itself, and so we'll be watching that closely. But that's also since we have backup command capability or communication capability with that gimbal, we're in good shape. So with that, I thought I'd take a minute and talk about the vehicles that are about to come to ISS, and then I'll pass it on to the rest of the folks to tell you what's going on orbit. The next flight in sequence is the ATV-3, which is in Kourou, getting ready to launch here on the 23rd, so at the end of this week. There was a delay. It was originally scheduled to launch on the 9th. We were looking at some closeout photos. Unfortunately, after the shroud had already been put over the ATV, and we found that some of the buckles were loose and didn't have the secondary locking feature installed. And so the decision was made to go ahead and go back in and snug up those straps and also put in the secondary locking feature. And then the spacecraft was buttoned back up and is on track to launch on time on the 23rd. We have dealt with a couple issues having to do with elevated levels of bacteria count in both on some of the surfaces of the bag and in the air. We have ways to deal with that. And in fact, in the case of the surface area on the bags, we have a higher constraint on the ground pre-launch than we actually have for the on-orbit requirement, and we meet the on-orbit requirement. So you can see that this is a level that we want to take a look at and think about and react to, but it's not really a constraint to launch. And so we'll process the paper for both of those concerns and be ready for the launch on the 23rd. And it docks on the 28th of March. Following that, then, we have a Progress that's coming up. 47 Progress will come up, launches on the 20th of April. Subsequent to that, then, or following that, is two things occur on the 30th of April. One is we have the return of the crew. Antonio, Anton, and Dan come home on the 30th of April. And also on that date today, currently scheduled, is the first launch of the SpaceX demo mission to ISS, which will plan to do its demo around ISS on the 2nd of May and be birthed on the 3rd of May. So that's in the plan. And then following that event, the next crew comes up. Gennady, Sergey, and Joe come up on the 15th of May and dock to the ISS on the 17th of May. Then later in the summer, although it's not been officially announced, we have a planning date to launch an HTV about the 21st of July. We're still finalizing that date, but that's the planning date we're using. And then we'll get it docked. There's a possibility we'll have a commercial launch in the August time frame. It's possible that SpaceX 1 could arrive then, so we're protecting that alternative. But then the demo flight for the orbital spacecraft will be occurring, launching on the September 1st and birthing on the 6th of September. So let's go back to the August launch. So if SpaceX 1 is ready to launch, we'll move the HTV to the Zenith port and be prepared to bring the SpaceX vehicle up and berth it to the nadir port and have two spacecraft up at the same time. If the SpaceX 1 flight does not occur in August, and from a logistics standpoint, that's not really a concern. We're in very good shape on orbit for logistics, so if it slips a little bit, that's okay. Then you'll see us go ahead and put that EVA to replace the main bus switching unit at that time. So now that's a whole lot of work that the crew has to do the berthings and the dockings and the EVAs. And in the middle of all that, we've made a commitment to the research community that we would obligate 35 hours on average a week for research, and we intend to meet that honor while doing all this work that I just told you about. So with that, I'll hand it over to Dina, who will tell you about what's going on orbit.
Okay, thank you. Well, good morning. Thanks for joining us. Things are going extremely well on orbit, and the crew's in great spirits right now. And I'm here to talk to you about Expeditions 32 and 33, and I'm going to start off by talking about the crew. Expedition 32 starts off with Joe Acaba, Gennady Padalka, and Sergey Revin on board. Going from left to right in the photo, Joe's our U.S. segment lead. He flew on STS-119. Gennady will be the space station commander for Expedition 32, which will make him the first three-time commander of the ISS. He was also previously a Mir space station commander. Sergey is a rookie flyer, and he'll be flight engineer too. In this graphic, the lower right photo shows the 31 Soyuz crew that joins Gennady's crew. Sonny Williams on the left will take over as Expedition 33 commander after Gennady Soyuz departs. She was a flight engineer on Expedition 14. Next is Yuri Malenchiko, who flew on Mir, STS-106, Expedition 7, and Expedition 16. Then you see Akihiko Hoshide on the right, and we call him Aki. He flew on STS-124. This crew of 6 is extremely experienced, with more than 1,300 cumulative hours in space before they've even flown this mission. And they have a combined 18 spacewalks under their belts. When Gennady, Joe, and Sergei leave, Sunny's crew of 3 remains on board for about a month, and then the 32 Soyuz crew comes on board. In the lower right, you see Kevin Ford on the left, who was the pilot on STS-128, and he'll become the Expedition 34 commander when Sunny leaves. Olev Nevetsky and Yevgeny Tarelkin are next. They're both rookie flyers, and they'll be the flight engineers. Sunny, Yuri, and Aki undock on November 12th, which ends Expedition 33. So at this stage, in addition to the Soyuz and Progress operations, we're very happy that we have almost all of our U.S. cargo arriving on Japanese and European and commercial vehicles up to ISS. And I have a video which shows, a depiction, as Mr. Seferdini pointed out, of how vehicle traffic might look in this summer time frame. Here you see the station's starboard side and the configuration it will be in at the time frame when Gennady, Joe, and Sergei are on board. The first vehicle I want to point out is the 30 Soyuz, which is the vehicle that Gennady, Sergei, and Joe arrive in. And this is their return vehicle as well. Next, I've highlighted the 47 Progress docked to the Piers module. This Progress vehicle is specially outfitted with a new external rendezvous and docking antenna that on future vehicles will allow them to delete 4 other antennas, although for this initial Progress docking, the standard antennas will be used. Our Russian colleagues are making this change because some of the original components are no longer easily produced, and the change also reduces mass and power requirements on future vehicles. On the far left, the European automated transfer vehicle, Eduardo Amaldi, is docked to the aft end of Zvezda, and the onboard crew will already have been unloading it and filling it with trash for disposal. Next, the 30 Soyuz arrives, carrying Yuri, Sunny, and Aki, and it docks to Razviet on Zarya's nadir side. After docking, the crew really hits the ground running with their post-docking onboard emergency training, some key science gathering associated with their first days on orbit, and preparations for the next vehicles to come and go. Following docking, they could have a quick series of 3 vehicles undocking, docking, and berthing in the next 10 days. So first, the Progress. Our Russian colleagues would like to test their new antenna and avionics. And if their test is successful, new Progresses starting in 2013 or 2014 will start incorporating this new system. So after its nominal initial docking, the crew will change out the standard avionics system with the new avionics internally. This 47 Progress will undock and perform some phasing burns that will take it out to 400 kilometers. We'll perform an automated redocking of the vehicle 2 days later using the new rendezvous system. Next, I'm showing you the H-2 Transfer Vehicle 3 arriving at ISS. We're planning on having Joe, Aki, and Sunny perform the track and capture by grappling the free-flying vehicle using Canadarm2. HTV has internal cargo, and it also has an exposed pallet with some attached payloads that will be extracted robotically. After HTV berthing, 47 Progress that I talked about previously will undock again, but this time for good. But 48 Progress quickly takes its place. At this point, the nadir port of Harmony is occupied by HTV, so our team, as Mr. Seferdini mentioned, is getting products ready to support the robotic relocation of HTV to the Zenith port, if needed to make way for SpaceX 1 and the orbital demo missions. We're likely going to complete our exposed pallet operations before that move. Next, you'll see Spacex Dragon, shown on that nadir port. SpaceX 1 is the second Dragon vehicle to visit, and it'll be berthed approximately 30 days. Next, I'm showing you orbital Cygnus docked to the nadir port, and we're looking forward to welcoming this first Cygnus flight. There are separate press conferences planned for the HTV, Dragon, and Cygnus missions, so you'll receive a lot more information about those in the future. Next, I've highlighted ATV, which will depart late in the increment. Gennady and Yuri will be in charge of the undock, and 49 Progress will dock to this port later. Next you see Gennady, Sergei, and Joe's Soyuz, which is the next to leave, at which point Sunny will take command. They'll have an extended period of 3 crew-person ops, and this is going to be about 1 month, which is much longer than the standard 2-week period. Then Oleg, Kevin, and Yevgeny Soyuz arrives at the same port, which is 32 Soyuz. And they're there until the end of increment 33 when Sunny, Yuri, and Aki leave, and Kevin takes command. So, yes, we'll be conducting a lot of research on board, and you can also see that it's going to be a very busy time with several vehicles coming and going. So, as Mr. Separdini mentioned, we are carrying a U.S. EVA on the books and also a Russian EVA. The U.S. EVA is U.S. EVA 18, and I have some graphics for that. Sunny will be EV1 and Aki will be EV2. There'll be an extravehicular mobility units, EMUs, on the U.S. segment out of the Quest airlock. The first task is the removal and replacement of that main bus switching unit 1, which we can't currently command to, and we'd like to get that replaced before the Russian multipurpose logistics module Nuaka comes up in 2013. I have a video. Here you see Aki on the top of the screen, and he's riding on Canadarm2 installing a new MBSU onto the S0 truss in the neutral buoyancy laboratory. Sunny's the free-floating crew member in the lower right corner. It's a pretty big box, about 3.5 feet long and 236 pounds. The crew will also be routing 2 cables. They're 38 feet and 70 feet long. These are power cables that we're going to route on the U.S. segment right up to the Zarya interface on the Russian segment. And these will be used to feed power to Nuaka in the future. So in terms of get-aheads, we do have one get-ahead associated with covering the PMA, and I have a video for that. Basically, we're going to install a protective cover over the end of PMA 2. Here you see them installing a similar cover on PMA 3 during the EVA on STS-135. We've improved the cover design to make it easier to install this time around. So other get-aheads include the prepping of the Zarya power and data grapple fixture that basically we have a grounding wire that we'd like to clear, and we would like to route route a cable to that in order to allow it to be used. So we have a lot to think about regarding this EVA, still quite a bit up in the air. And now I'd like to talk about the Russian segment EVA. It's the Russian segment EVA 31. The EVA is going to be in Orlan spacesuits out of the Piers module. Gennady will be EV1 and Yuri will be EV2. The first priority is going to be to install 5 shields on the Zvezda module. These shields reduce the likelihood of hull penetration should orbital debris strike the area. The crew is also going to be relocating a Strela boom from the Piers to Zarya. On the graphic, you see Strela 1 extended to Strela 2, since Strela 2 is going to be used to Strela 1 is going to be used to move Strela 2. On the next graphic, you see Strela 1 moving Strela 2 over to Zarya on the forward end, and on the right you see its final location. Right now the crew is also planning to release a passive spherical satellite that will allow our Russian colleagues to evaluate ground station tracking and modeling for orbital debris. In the photo on the left, you can see the sphere, which is 13 kilograms and 53 centimeters in diameter. Of course, we'll be analyzing this from an orbital dynamics standpoint. In the second photo, you can see a tool for holding the satellite on the right with someone demonstrating the deploy and a mock-up of the satellite on the left. So the get-aheads for the EVA include bringing in some material exposure experiments and also installing some struts on the Piers EVA ladder. And so another interesting effort that we're talking about for this increment is adding on board instant messaging and also sending up to the crew some more automated procedures or autonomous procedures that involve the ground a little bit less. And these 2 items are really to gather some data so that we can work towards an experiment in the future with a comm delay on ISS. Essentially, this is not something that's right around the corner, but we wanted to get these 2 these two items on board at this time so we can gather some information. You can imagine that you might need some sort of countermeasure for a comm delay, and so instant messaging might be something that you could use, something kind of like an email, that kind of thing for communication. So we're looking at those types of things on this particular increment. And additionally, I wanted to talk to you about 5 small satellites that we're going to be deploying. These are called CubeSats, cubic satellites, and I have a video for that. The satellites launch inside on HTV, and the crew installs them on a deployer on a platform that gets transferred to space via the Kibo airlock. The GEM RMS grabs the platform, packed with the satellites on it, and then moves it out to a location away from structure. There are 3 satellite units per rectangular deployer. A door on the end of the deployer opens, allowing spring force to push the satellites out. One satellite is 20 centimeters by 10 by 10, which is a double unit, and the rest are all 10-centimeter cubes. Each CubeSat has experiments conducted by universities or industry. So that's an overview of Increment 32 and 33 operations. Thank you for your time. At this time, I'm going to pass it over to Tara, who's going to talk to you about the interesting science that we're going to be doing during this expedition.
Okay. Thanks, Dina. I'm happy to be here, and I'm hoping everybody stayed dry on their way over. I'm excited to talk the research. To me, it's always one of the coolest things happening on station. And I've seen as we transition into the next decade of utilization, our teams internally have been really busy managing and processing the research that's coming and going. And I've seen the crew on orbit is just as busy implementing it. So we're looking ahead to meeting the full research objectives that were created when Space Station was first envisioned. And I think everyone, as I'm hearing from scientists to students, are anxiously anticipating what's to come now in the next decade of Space Station research in relation to this unique orbiting laboratory, which is what it is. So to date on station, there have been nearly 1,300 investigations performed through Expedition 30. This represents over 1,300 scientists worldwide in 65 countries globally. Through the remainder of this year, there will be over 200 investigations performed in the areas of human research, biology and biotech, earth and space sciences, physical science, technology development, and education. Each of these investigations will provide knowledge that advances the human exploration of space, improves our daily life on Earth, and contributes to our own fundamental knowledge through new discoveries. No laboratory on the planet allows scientists to perform sustained, repeatable measurements of their data while controlling for gravity. And no unmanned orbiting vehicle can provide the combination of automated and real-time human-tended constant observation of the Earth's ecosystems and natural disaster events. No laboratory on the planet has inspired the scientific creativity in over 4 million students in the U.S. alone. Although hundreds of investigations will be performed on Space Station during Expeditions 32 and 33, today I only have time to tell you just about a few of those and their relevance in the research program's portfolio. So first I'll tell you about one of the new research facilities headed to Space Station on HTV-3 this summer, and that's of primary importance to our Japanese partners, and that's the Aquatic Habitat. The Aquatic Habitat will house small freshwater fish such as medaka and zebrafish, and it'll allow scientists to watch them grow over generations on Space Station and understand the physiological changes that happen in these small model vertebrates. The Aquatic Habitat has 2 transparent aquariums designed for the microgravity environment. It consists of environmental control systems and CCD cameras for imaging, including infrared. The first investigation in the Aquatic Habitat is actually planned for next year, and will look at changes in skeletal composition of fish grown in a microgravity environment. Because we know that bone density is lost in astronauts at a rate of about 2% per month on orbit, studies like these are critical to keep our astronauts healthy. And the data collected from investigations like this will also contribute to better understandings of debilitating skeletal skeletal conditions that we see here on Earth, such as osteoporosis, which currently affects an estimated 75 million people in Japan, Europe, and America. The space station also offers unique opportunities for observing the Earth, both from terms of orbital characteristics and human and infrastructure support. A new investigation called the ISS Surveyor Environmental Research and Visualization System, or ISERV for short, will arrive at the space station on HTV-3, and it'll serve as a pathfinder to increase Earth imaging capabilities that could be used to support disaster assessment, humanitarian assistance, and environmental management. This investigation is part of the Surveyor program, which is a joint partnership between NASA and the U.S. Agency for International Development, or USAID, that allows people in developing regions to access data about the Earth for a variety of purposes. The iServe is a fully automated Earth imaging instrument that will be mounted Earth-facing in the optical quality window within the wharf in the Destiny Lab. And to give you an example of the types of images you can get from the space station, this is a picture of Hurricane Isabel taken by astronaut Ed Lu from the space station as it headed for the U.S. East Coast. And images like these have been used by global organizations such as the National Hurricane Center to characterize storm dynamics and plan for appropriate response. So this is just one more example of how the Space Station Partnership is working to maximize the benefits of the vehicle as an Earth observation platform. Along the physical sciences front, the new Advanced Colloids Experiment 1 that will begin this fall is the first in a series of complex fluid investigations that will explore how colloids behave in microgravity using the on-orbit light microscope. Because colloids are the basis for many of the materials we use here on Earth, understanding their behavior under different conditions could tell us how to improve many of the products that we use, such as household cleaners, foods, and medicine, as well as how to engineer brand new ones. It's also important in the design of spacecraft materials, improvements in propellant, and enabling us to have long-term stowage of goods and products on longer missions as we go below low Earth orbit. On Earth, it's tough to study colloidal behavior because under the force of gravity, particles tend to settle within their fluid. So scientists don't get a true representation of the particle-particle interaction, and so you can see an image of the colloids on the bottom of your screen there. Removing gravity allows us to watch the natural interaction of colloidal systems as they remain suspended over an infinite amount of time in a microgravity environment. So you get a true visual of what their behavior is like without the gravity masking their behavior. So you're looking at an image of Dan Burbank now, currently on orbit, and he's actually been performing the preliminary experiments on the light microscopy module in that picture. He's looking at different samples under different conditions to ensure the microscope is ready for the ACE-1 investigation this fall. The space station is also the ideal platform to advance space technology, and I'll discuss two of these demonstrations today. The first of these is the Robotic Refueling Mission, or RRM, which is a joint NASA and Canadian Space Agency effort. And the purpose of the RRM is to operationally check out and test a mock-up satellite for potential refueling on orbit. The first operations actually started a few weeks ago, and the point is to robotically service and refuel satellites in space. It's something that can't be done right now. The RRM hardware is located on the ELC position of the External Space Station Truss. And again, it's a satellite mock-up about the size of a washing machine that provides activity boards and tools to practice these servicing tasks. Operations are actually remotely controlled at NASA and CSA's Control Center, and the first fuel servicing is planned to occur during Expeditions 32 and 33. And we actually have a brief animation of what this is expected to look like. And we begin here with Dexter using the safety cap tool to remove the safety cap from a fill and drain valve and allows access for refueling. On real satellites, the safety cap helps prevent hazardous fuel from leaking while a spacecraft is still on the ground. And now the safety cap tool is going to be, and the cap is going to be stowed away, and we'll move on to the actual fuel servicing task. Dexter here switches to the nozzle tool with the robotic fueling holes with the hose to transfer the liquid ethanol fuel through the fill and drain valve in a closed loop. So RRM carries about 1.7 liters of ethanol fuel for this demonstration, and there's a demonstration of the transfer. And after the fuel transfer, the fitting is left behind, which on a real satellite refueling mission would give easy access to the fuel valve on a return visit. RRM will remain on the space station for 2 years and will lay the foundation for potential fuel servicing missions in space. The second investigation making use of space station as a test bed for advancing space technology is the Space Communications and Navigation Test Bed Investigation, or SCAN test bed. Scan Test Bed will be the first software-defined radios that will be sent to station that will allow engineers to actually change the software on these devices even after they've launched. So, for example, ground controllers will be able to reprogram these radios to change the type of data that needs to be transferred depending on the experiment, depending on the situation. And this includes data such as video, telemetry, and voice, just to name a few. The Scan Test Bed will launch to the station on HTV-3 this summer, and the robotic arms will move it to its permanent location on the external truss, which is what you're seeing here as it's being placed. Scan will allow researchers to conduct a suite of experiments over the next 5 years that will enable the advancement of a new generation of space communication. Now, the antenna you see that's about to gimbal will allow communications between NASA's relay satellites and ground station around the U.S. So we're really looking forward to seeing what Scan Test Bed can do for us for communications and data transfer. And we're excited about all of these investigations that are going to be implemented in 3233. So you can see from the breadth of these experiments that station is really realizing its potential across all the disciplines. We're excited to get to work with the crew to start these investigations and the other hundreds of others planned for the remainder of this year. And thank you very much.
All right, thanks, Tara. Just a note here that for the first time here in Houston today, we're going to be taking some social media questions during the briefing. Anyone who'd like to send a question in via Twitter should use the hashtag of @AskStation, and we'll try to get your question answered as we have time. We will first of all, however, go to media here at JSC and then at the Kennedy Space Center in Florida. Please, if you have a question, come to the microphone and ask it, and then we'll move on to the next ones. Any questions here in Houston? Jim?
Jim over for NBC. Good morning, and thank you for sharing the time. Dina, you mentioned this com delay issue, and the question is really for Mike. There's talk about using the ISS as the location for an analog mission, a reflight of the Russian Mars 500 long-duration mission. Are we really looking toward missions in the next couple of years that could last could people in orbit for 2 years or longer? Is that sort of thing being discussed? And can you just assess, is that scientifically or medically feasible?
Well, clearly, in order to be able to explore beyond low Earth orbit, we're going to have to stay in orbit a little longer than 6 months. And so one of the things we have been talking about for some time, in fact, since the advent of a low Earth orbiting platform, is its benefit for human research. And part of that, of course, is determining how long the human system can survive in a microgravity environment. And can it survive a microgravity environment for an extended period of time and then land on a foreign planet and expect the human to be able to do his or her tasks while they're there, and then return home again, experience the same microgravity environment for an extended period of time. So that's a long-winded way of saying yes, we're considering that. We're talking to our partners about that. In fact, it was a bit of a discussion during our heads of agency in Quebec about some of our offline discussions were about what steps do we need to take to put ourselves in a position to be able to extend the crew's time on orbit as part of the human research study on the human system's ability to withstand long duration space flight. So absolutely, that's part of what we're looking at. And what Dina will tell you about here in just a second is really the beginning of a set of simulations that were to also include extension of the crew on orbit. But as you said, that's not an activity that's going to occur tomorrow. We're taking steps, and we will evolve to this point over a number of years so that we can get all the data we need before the end of the ISS lifetime.
Okay, and then so related just specifically to these particular experiments, we talked about instant messaging, and this is like a chat feature and that sort of thing. So you can imagine if we had Capcom or flight director calling up to the crew and there was a significant delay, this would be in some future mission, that you'd sort of wonder, well, did they hear me? I have something else I want to add, and it's more difficult to have a conversation with a comm delay. So potentially we're looking at something that would be more akin to email or a chat feature. So we're talking about doing that on this increment. And additionally, the crew, if they're going to go land on some foreign planet or go out into deep space, onto some other mission, you could conceive of it being difficult for them to have a conversation with the ground if some piece of equipment breaks. So we would want to make sure that we would have all kinds of contingencies sort of in place in our procedures. Well, if you can't find this cable, use this one. Or if you have trouble with this wire, then this is our recommendation. So what we're going to do is put some slightly more autonomous type procedures and stowage information and that sort of thing on board for the crew, so they would rely on the ground less on this particular experiment on Expedition 3233. So that's kind of a lead-in, and we're really just sort of laying the groundwork and getting some of these tools ready, and we're basically working our way up to an eventual type of comm delay kind of experiment, but that would be a few increments in the future.
Okay. Mark?
Medically.
Oh, medically, yes. Our numbers, our sample sizes for any human being that's gone beyond a year on orbit is really small, right? So those are the things that our flight docs and our scientists are working internally to figure out and determine the best approach to that. Medically, as we know right now, there are challenges to the physiological system that we're not ready for if we were to plan for Mars, for example, tomorrow. So this series of analogs that Dina and Mr. Safradini have talked about will prepare us for that, but the flight docs and the scientists internally are off figuring those things out.
Thanks. Mark Carreau, Aviation Week, and I had a question for Mike Safradini. About a year ago, with the final shuttle missions queuing up, you were preparing the space station to go a year without resupply, and I wonder how that forecast is holding up, and I believe you did touch on that during your portion of the briefing, but I'm sort of looking at, how, at this point in time, how long are you good for if you still didn't get the commercial resupply?
That's a good question, Mark. And yeah, I did try to say that from a logistics standpoint, we feel like we're covered for a good while. At that time, I don't remember the specific briefing, but we had estimated for some time that we could get, with STS-135, we could get ourselves in a position that, given STS-135, the upmass we'd already had planned on Progress vehicles and the upmass that would come up on the other partner vehicles, the ATV and HTV specifically, that we thought we could get to the end of 2012 with normal operations on board ISS, meaning we have enough upmass to do not only the consumables for the crew, but the full suite of research we wanted to do. And in fact, now we think that we could do a little bit better than that and get into the early 13 time frame. We have commitments. As you recall, we lost a Progress early on that had quite a bit of upmass for the U.S., and so we've been working with our Russian colleagues to front load that upmass in the early 2013 time frame. And so that's helping us get into 2013. So we're in really good shape from a logistics standpoint. And of course, our partner vehicles have moved to the right. We think that's prudent for them to really focus on the details as they get close to flying. Look at all the data, look at all your test data, make sure you understand it before you go try to fly. And so we, from my perspective, things are taking the right amount of time. We're being thorough. We're not rushing either of the two commercial providers to the launch pad, and we're able to give them that leeway because of what we did with STS-135.
If there were difficulties or more development time was needed, is it possible to estimate I guess your estimate is early 2013, and then you would need some sort of decision on adjusting to the logistics?
Yeah, there's variations on that. I would tell you, we still have the partner vehicles in those years, and before we had done analysis, as long as we still have HTVs and ATVs, we could probably keep the crew on board, but we wouldn't be able to do much in the way of research. So we're not talking about a situation where we're going to return the crew home. We're talking about a situation where we won't be able to fully utilize ISS the way we'd like to. With that said, we do have means. We could still talk to our Russian colleagues perhaps about flying. They don't have extra vehicles. That's a 2-year call-up kind of thing, 2+ year call-up thing. But we might be able to work with them to find more margin on their flights and make some trades to minimize the impact to research. And we would begin those conversations, of course, before we get too close to the period where we had to have it, in order to see if we could provide enough upmass to keep the research going. I would tell you that in some areas of the consumables where what we call, the term we use is fat. So we've got plenty of water on board. We've got a lot of food on board. Crew supplies is something we can work through. So as we get later in the flow, as we get, for instance, to 2013, the first quarter of 2013, if we need the additional upmass on the Progress, we'll probably try to focus that upmass more on research because we're in pretty good shape relative to the rest of the supply. So it's not that everything is going to be low come 2013. Some things will start to push the limit, so we'll take care of those, and meanwhile use the rest of the upmass to keep the research going. But again, we're not getting to a point where we're gonna have to de-man ISS with the cargo, with the vehicles we have, the commercial vehicles we have. We'll be able to keep ISS manned. We're talking about being able to continue to do research, which of course is a very big deal. That's why station is there, but it's not as traumatic as losing the crew.
My name is Ken Obara from NHK Japanese Broadcasting Corporation. I think you realize, but we got a lot of Japanese media here. One of the most things that we're very interested in is the upcoming launch date of Aki's launch. I was pretty much hearing cautiously, but I didn't think I might have missed the launch date or the predicted launch date of Aki's launch. If you could tell us what the current situation is. And number two, you mentioned about Aki's spacewalk, but you also mentioned that it's a little bit up in the air. Could we say that Aki will be doing a spacewalk, but it's the content is still a little bit, or is it still up in the air on whether or not he is going to do a spacewalk?
Let's see, the launch date for Aki and his crew, so we'll fly Yuri and Sunny as well, is the 15th of July, and they dock on the 17th of July, and that's the current launch date. Don't be too bold with the EVA. Crews love to do EVAs. Unfortunately, EVAs take quite a bit of crew time to prepare for. The day they go outside is a small portion of the overall 100 or so hours that it takes for crews to get ready. And so we try to only do the EVAs when we can fit them into the timeline. First, we'll do them when they have to occur. But if they don't have to occur, if we're not driven by a contingency case, we try to fit them in where they fit. So if the SpaceX flight doesn't occur, then odds are we'll have a scheduled spot where they can fit. But if we don't make that date, as I recall, the dates start to get closer to December that we find the next spot where we think we can fit them in. So it's not a given that we'd find an opportunity, although it's very likely that Aki will go outside.
Okay, Rob.
Hi, Robert Perlman with CollectSpace.com and Space.com. Mike, I believe you mentioned utilization time for the crew of 50 hours per week right now. Can you talk a little bit about how long that extended amount in terms of catch-up is going to be extended? How long it's going to be 50 hours, or if it's going to drop back down to 35 hours?
Tara will help me with this one. I thought if we got to the end of increment 30 with the 50 hours, we could get 35 between 29 and 30. Is that right? Okay.
That's right.
So at the end of increment 30, which ends with the return of this next crew.
And with the talk of instant messaging and such, there's also been talk on orbit by some of the crew members about the desire or use of tablet computers like the iPad. Are there plans from the U.S. side to launch tablets for operational use?
Yes.
Is there a timeline for that? And have you picked out a model?
I just had a conversation about that. Somebody is working on picking out a model. It hasn't come to me for a decision yet.
Okay.
And they're looking at the standard ones that you'd probably be interested in at the store. And We're actually, the crew's interest in it is to, so today we have procedures and stuff on the laptops they carry around, and they've been talking to us about if you can get this board that they can Velcro to their knee even and take with them, that it would make it simpler for them to get procedures around with them where they're at. So that's one of the big applications for it. If they're just doing email and stuff, it's just as easy to do it from a laptop. So there is a procedural application that we like, and we're looking at options to for laptops. I mean, for the right one to fly and certify it to go fly. But I don't think we've decided on the model yet. I remember a discussion about it a few months ago, but I don't think we've picked one yet. We can verify that, and we'll let you know through the system.
David Hirsch, NHK. Kind of a follow-up to Mark's question, if I could, on the C2, C3 flight. You mentioned May 2nd as being a rendezvous day and May 5th, I believe, for berthing. When we were on a conference call about a month or so ago, you gave us an idea of what was standing in the way between getting that mission off and now. If you could update us on what you're working and how likely I think it's April 30th, looks to you as being a firm launch date for that.
You know, I'm just sitting here thinking the simulations are taking place. We had a trajectory tool that we were working on, SpaceX was working on, that we were evaluating with them. That's done and being used in simulations now. That's going well. They needed to paint the service module part of the spacecraft in order to take care of a thermal issue with tanks. I think that one's behind us. I think in the end we didn't end up having to paint the spacecraft. We've inspected the engines, so I don't know of any issue there. I don't know of any big drivers right now other than just what they have to do between now and launch date off the top of my head. But still, there's still work to be done and getting ready for loading, doing their final tests, buttoning things up. So there's a lot of work to do between now and April 30th, but their schedule supports it as we see it today.
Okay. I know we have reporters at the Kennedy Space Center in Florida, so let's go off to Florida right now and answer their questions. We'll come back here as we have time a little bit later.
Yes, hi, this is Marcia Dunn of the Associated Press with a couple questions for you, Mike. For the Dragon launch, I'm wondering what is the payload? What have you decided to put on board to take to the space station to benefit the crew? And could you sort of talk a little bit about the demo that's going to be involved, the complexities, all that sort of thing involving how you want to make sure it's good before it comes in for a grab?
Sure. First, the payload. We have between 400 and 500 kilograms of upmass. It's low sodium food, some crew supplies. It's not one of a kind ORUs, but it is important cargo all the same. And we're going to learn two things from the demo flight. One is, can you berth? The other is how we unload and reload and efficiencies, and learn from that as well. So actually having actual supplies on board that we need to do something with when they get there, as opposed to just dummy cargo, is really a big advantage. Of course, from the standpoint we get real cargo out of it, but also it's going to help us understand how most efficiently to unload and reload the Dragon spacecraft. So I don't have the precise number off the top of my head, Marcia, but it's in that area. Let's see, as far as the demonstration, and we'll talk about this when we have the press conference before the flight, so we'll give you a little more detail on it. But first of all, as the spacecraft is flying towards ISS, there's information you gain from the models the environmental models you created that you expected the vehicle to be reacting to, and how the vehicle actually reacts to it. And so the first thing we're going to learn is modeling and how the vehicle is operating with respect to how SpaceX believed it would operate. And of course, some of that's been learned a little bit with their last flight. And then as you get close to ISS, there is some specific testing of the long-range rendezvous capability and near-term prox ops capability. So we'll fly under the space station to do the relative GPS to make sure that system works correctly. We'll, of course, in the process of doing that, we'll communicate with the vehicle to make sure the UHF comm system is working together. And then what we'll do is sort of do a big fly around of the space station, which should take us about a day. We'll assess that data against pass-fail criteria that's in the flight rules today. If we pass, we're done. The rest of the approach and the berthing can occur. And if we don't pass, we'll talk about it. And the agreement is, unless it's proved at the IMMT, they will then go and hold as part of that pattern. They'll go hold, and we'll sort through the issue, and then let them approach once we've sorted it out. But then the next day, what happens is we don't just fly right in. We actually come in and we fly up a little bit to R-bar, and we get the close-in systems working, the LiDAR systems, and then we'll practice an abort away, and we'll board away a little way, then we'll hold, and then eventually we'll look at the data, and then we'll finally come up into the berthing box and berth. So we've got a couple of cases where we're going to test the far field rendezvous system and comm system, and then the next day we'll get the close-in prox ops systems. It will test the abort capabilities. There's another board actually we test further away from ISS as well. So we'll test the final abort capability, and then assuming it meets all the criteria that's predefined in the flight rules, we'll come up into the berthing box and let the crew grab it.
Thanks on that. Two more questions, one of which is, from where you sit, how important is this demo flight? How important is it for it to go well and to succeed and to pave the way for commercial cargo hauls to the space station?
Well, that's a great question. So of course, you want every flight to work exactly as you planned it. But we had initially planned on 2 demo flights, and so if something happens during this flight, regardless of what that is, we will learn. SpaceX will learn. And then we will have to sit down and say, okay, now did even though it perhaps didn't make it all the way, or we had some problems along the way, we will assess that and go, okay, now is it necessary to do another demo flight before we decide we're operational, or do we assume we'll pick up the last piece of demonstration on a CRS type flight? Of course, the difference between the two being how much we loaded up for that flight. So that's forward work. So I would tell you, Marcia, we need to be careful not to assume that the success or failure of commercial space flight is going to hang in the balance of a single flight of the first SpaceX flight. Both of these companies are committed. The agency is committed to supporting these companies for them to be successful. They're building very capable spacecraft. So if they have problems along the way, it's the kind of things that you experience in this difficult process of trying to not only launch into low Earth orbit, but do the next hardest thing, which is to try to rendezvous safely with another spacecraft in orbit. So there's a lot of challenges with all that, as we say, or at least one of my mentors used to say, it's the first 50 feet and the last 50 feet are the hardest. And so they have to do both on this flight. So we're going to learn, and if it's not a complete success, we still learned quite a bit, and we'll move on to the next flight based on what we've learned and do it as well. And as we've said, from a logistics standpoint, we're doing pretty good, and we've got a little margin in the system, and so we need to treat this as what it really is, which is a demo flight. And as we all know, demonstrations don't always go exactly as we planned, but that's why we do demonstration flights.
Thank you. And the last question from here is, it's been 8 months since the last shuttle delivery. How is it going without shuttles to bring up and bring down? I'm just wondering the status in orbit without the coming and going of the big shuttles as they once did.
Well, we'd reached a point. Well, first of all, I miss my shuttle friends. The shuttle was an amazing vehicle, and personally, it was fascinating to watch and to try to utilize. But we had finished assembly of ISS, and we no longer required a vehicle of that capacity to just service the ISS. And so from that respect, we're not missing the shuttle. Now, there were things that the shuttle was uniquely able to do that we don't get with smaller vehicles. And that's okay, because that's where we are in the life cycle of the ISS. And really it's time for us to focus not on big missions that we end up racing through the work to do a major mod to the ISS, but rather now's the time to have the logistics vehicles show up. Logistics vehicles that can stay a while the crew, while they're doing their other jobs, can empty it out as necessary, eventually do the external offload and reload, and then depart in a manner that allows us to continue the other things we were doing before the vehicle arrives. So in some respects, these other vehicles that service ISS are more adapt to how we operate today as opposed to the assembly phase. So while the shuttle was a very, very capable vehicle, it would have been overkill to maintain the ISS long term with that vehicle. Now, the piece that we as a country are working on and should, of course, is the alternate means for rotating a crew, which we do miss without a shuttle, and we are, of course, as you know, working towards creating an alternate capability, so we have a backup way to get to ISS with crew.
Okay. And Tara, did you want to address research?
Yeah, so with regard to payload capabilities of the vehicles that we're using now versus shuttle, we've actually had even more room than we've ever had on shuttle in terms of volume for payloads up and down mass, or at least up mass. And so we've been able to implement our research complement, and we're also looking forward to SpaceX. Even SpaceX Demo has an investigation on it, and that's the NanoRacks investigation. So with the SpaceX complement coming up, we will have up and down mass, and so we're looking forward to that capability to bring our samples home. And so we've had good progress so far without shuttle. At least with regard to research. And so we're, again, looking forward to SpaceX and Orbital coming online as well.
And then I'll just jump on the bandwagon a little and point out that, I think that there's, folks might think that things have gotten kind of less busy now on space station, but it's incredibly busy. First of all, the research that Tara mentioned, this really takes over a huge amount of the crew's day. It's really exciting to watch the crew. They're talking to scientists around the world, and they're doing some incredible, incredible research. Additionally, we have all these vehicles coming and going, and it's really busy. It seems like the assembly phase. So I don't want folks to think that things have just slowed down on space station. It's really not the case.
Okay. We have a couple of questions on the phone bridge today. Let's go to those first, and then we'll take some of our Twitter questions. Philip Sloss, are you on?
Yeah, can you hear me? Yes. Can you hear me?
Yes, please go ahead with your question.
Yeah, this is for Mr. Suffredini. Can you provide a status on failure analysis of the pump module that was brought back on STS-135?
I can tell you that we found that ammonia had leaked into the stator area of the pump, which ultimately resulted in the failure of the pump. We have not determined the root cause of whether or not we had some, whether or not the bearings had gotten worn to the point that they started to allow rubbing, which caused the leak in an ultimate failure, or whether the leak occurred and then this caused a reaction that resulted in the ultimate failure. That's still work in front of us, and it's been a long process, because as of course, as you know, the ammonia pumps ammonia, and that's a hazardous substance, and in the process of disassembling it, we found ammonia in areas we hadn't planned, and so it's taken us a while it took us a while to get it all disassembled and do the analysis you do as you disassemble it. You just don't take all the pieces apart, as you know. You take it a little at a time to make sure you don't destroy the evidence. So it's been kind of a long process, but the pump is all disassembled. We know what occurred. We're still trying to determine root cause. I would tell you, though, that we've been looking, we keep very close track. There was a couple-month period beforehand where we started to see signs this pump was having these problems from a current perspective. And we pay very close attention to these pumps from that perspective and have not seen any indication of a similar concern with the pumps that are running on orbit today. So we still have a little ways to go in determining root cause on the pump module.
Okay, thank you. That's it for me.
Okay, and I believe we have Todd Halverson on the line.
Thanks very much. Todd Halverson of Florida Today for Mike Suffredini. Mike, I'm wondering if you could tell us what the earliest date is that you believe you guys might be able to fly an analog-type Mars mission on the space station. And could you also update us on your analysis of how long the station could actually operate? I think you were looking at whether it would be structurally good through 2028. Thanks.
Let's see. The answer to the second one is, of course, we're approved through 2020, and we haven't actually completed all of our analysis through 2020, but it takes time, and it really, from a 2020 perspective, you have to just approve or complete the analysis on all the components that flew before the Columbia accident. All the components that flew after that actually don't reach their 15-year life until 2020 or beyond. So anyway, that analysis is still going on. We actually finished that in the late 2013 timeframe, but all the data we've seen so far is very positive. And so as we've stepped through the older elements first, we haven't seen anything that causes us concern. We still have work to do to close out a couple of areas, and then finish up the newer modules, which you would expect will not have don't have as much life, and so you would expect to be easier and clear. All of the work we're doing, as you said, however, we when we began this process, since what the law says is 2020 and not to preclude going beyond 2020. We kicked off the effort assuming 30-year life of the oldest elements, which gets you to 2028. And again, we're still doing the analysis. We got even further to go to get to 2028 with some of the components. But the life work we've done, we're doing in phases 1, 2, and 3. We're just about done with phase 1. Phase 1 was all the elements flew up through the airlock, the 7A flight. We have some question mark areas where you have to go in and then do a more detailed analysis to clear certain areas, but all that analysis is assuming 2028. And so that's all the work we've been doing. So as we go a little further along, as we clear the phase 1 effort and move to complete phase 2, we're completing it all the way to 2028. And my prediction is while we may have to do 1 or 2 things to clear a couple of individual components to get all the way to 2028, I don't expect it to be anything overwhelming that would be a driver to us not extending the life of ISS.
And then a question about the analog.
Oh, I apologize. Thought I was done there. Analog. It's a little too early, Todd, for me to quote times, but it won't be in the near future. It's probably not reasonable to expect us to be able to do this sooner than 2 or 3 years from now to get started in that process.
Anything else, Todd?
And I need to clarify that, Todd, before you run away. As Dina says, we actually are already starting the work towards that. I assumed your question meant that we'd be extending the crew on orbit, the crew's on orbit time, and that will take us a little while to get to the point in our process of gaining more and more experience of long-duration spaceflight that we do that. And one of the things as part of the human research effort that we have to discuss, and it's already come up, is do you reach equilibrium in 6 months? I mean, is it reasonable for us to assume that anything after 6 months, if you've been able to mitigate the effects for 6 months, does that mean you can mitigate the effects for a longer duration travel? But you have to think about that across not only the physiological issues, but the psychological issues as well. And so that's part of what we will discuss as we go. I would expect, however, that the consensus of opinion will be that we'll end up wanting to simulate in low Earth orbit at least the first leg of a trip to a distant planet.
That's it for me. Thanks.
Okay, thanks, Todd. Let's go now to our first Twitter questions.
Okay, we have a couple of questions here from the public on Twitter. A couple of them are two-part questions, so 2-for-1s. The first one is a two-part question. This one comes from @Risby. How do you guys communicate with the ISS crew, and how do you get data?
Should I take that?
Yeah, I think you should.
Okay, so how do we communicate with the crew? Excellent question. So as one location that we communicate to the crew from is Houston in Mission Control. So you can envision Capcom sitting there with his headset on and talks into the headset, and that goes throughout the building. That information gets transmitted over to White Sands, New Mexico, and then up to a tracking and data relay satellite system. And then that gets transmitted over to a space station, and then of course the crew hears that on speakers or on their headset. And the data path is the same way. So we have a bunch of sensors all over space station, and those are gathering data, and then all that information gets what's called multiplexed together, and this data package gets sent like a bunch of bits over to that satellite, down to the ground in White Sands, and then back over to Mission Control. Now, something to think about is that we have a lot of international partners and also a lot of payload experts and scientists around the world, and so, of course, that information then further gets transmitted out to those folks that need it. And additionally, we have voice communication. We have a Japanese Capcom, essentially, and we also have a Capcom, essentially, in Huntsville and also in Europe. So we have a lot of ways that we communicate with the crew. They also even have kind of a telephone that they can communicate as well. So I think that kind of summarizes our data and our voice path.
Great, thank you. Okay, so we have another one from Quincy Sewer. What will the ISS be like 10 years from now?
Well, it'll look, let's start with what it'll look like, and then what it'll be like will be an interesting one to see if I can come up with an answer to that. It'll look, let's see, in 10 years, our Russian colleagues, as we mentioned, will add a module called the Multipurpose Laboratory Module. That's coming towards the end of 2013, as we understand it, and it will have a docking ball on the bottom of it as well. We are going to add docking. We already have 2 APAS docking ports, but the team is looking at international docking standard and having that implemented in time for the commercial crew vehicles to show up. So from a outside looking in, it'll look a little different. We'll probably still put them on the PMAs, and so it may be hard to notice. In addition to that, I'm thinking there's going to be some research opportunities are going to bear themselves, and we'll be utilizing additional ports. One is there's been some discussion about perhaps a demonstration of an inflatable module that we would bring to ISS for some time, inflate and see how it works in the around the confines of ISS to decide if it has applications for the future. If we look beyond 2020, you may even see another solar power module on the Russian segment to provide additional power to it as they try to do more and more experiments on the Russian segment, and the solar arrays that are on orbit today get a little older and a little less efficient. So from the outside, it'll look a little different, but not dramatically different than it looks today. Would be my answer. How it's going to operate, I think you're starting to see the evolution of where we're going to end up. The operations team is going to be in the background running, like Dina said, doing amazing things, because there's going to be anomalies to solve. There's going to be vehicles coming and going, crew members doing EVAs, but you're going to see the focus is going to be on what have we done on ISS. It's going to be more of what research did you do. Getting things done no longer is about the assembly job or the maintenance job. Getting things done is about what research we did for who and what the benefit is to the Earth. And the operations piece will, while still be going on, will start to, I think, evolve a little bit more towards the back seat until the next major problem occurs, and then we'll all remember that the ops guys are there and why they're there. But but I think that's the evolution we'll see as the program, I hope, as we evolve over the next few years, that we'll really begin to see why ISS is there, the benefit it has to humankind in general, and start to look for that each day. What happened on ISS today? What's going on? What's the application for my life on the ground? And a lot of that is going on, as Tara told you, and I hope that comes to the forefront as the years go on.
Okay, thank you. Now we have another question. This is another two-part question. It comes from Cecil IT. How much technology is being used in this mission? And the second part of the question is, and what safety measures are in place to make sure everything runs perfectly?
Well,
Tara, you want to do that?
Well, with regard to the research, I'd say about 1/3 of what happens is technology development, 1/3 to 1/4. And at least for 32, 33, now I see things as we go through the research planning process that cross our desk that look like technology demo is ramping up significantly. So as Mr. Suffredini talked about, one of the things could be the inflatable habitat addition. Right now, on orbit, we have Robonaut 2 that's a tech demo. We have the robotic refueling mission that's a tech demo. It actually started 2 weeks ago, but it's planned to continue through this expedition. And so with regard to the research that's being done, our technology demonstration portfolio is really ramping up as I see it across my desk on a regular basis. With regard to the second part of the question, I'll turf it to Mr. Suffredini.
Well, again, for ISS, we take advantage of technologies, operationally speaking. We're actually flying a new radio where we've got about 7 ORUs, orbital replacement units on orbit that are being replaced by a single unit, and these units are flying up here in the summer time frame, and you'll start to hear them rewiring the ISS for this high rate comm system. That's a case where we've evolved technology to utilize on orbit. You'll also see us use more technology that we use on the ground day to day. You heard the thing about using the iPads and other technologies like that we're trying to evolve to ISS. But it's always a balance for us because you're trying to. We're trying not to modify the vehicle unless we have to. Now our job is to get the most out of it. And when we do the modifications, if they're critical systems, to some degree you need to make sure that you have the heritage to ensure that they're going to safely perform the functions that's required. And so that's more the push for us. Technology tends to be those things that you utilize to accomplish objectives you couldn't otherwise accomplish. And so while we will implement technology driven changes on board ISS, I would see more and more of the technology you see on ISS will be the demonstrations of a technology we use to explore beyond ISS.
Okay, thank you. So our followers are definitely watching. So we have one more zinger, and I think this one's going to go for Tara. The question is, what is the longest running research project on the ISS? And this comes from Karen Lopez at DataCheck.
Oh, wow. Okay. Longest running research. Probably, there are 2 that come to mind. There are actually 3. There's repository where there's continuous collection of bodily samples from the crew that the crew offers to return home. And it's a repository of physiological specimens, blood, urine, and that goes here to JSC and it gets stowed away for future use on upcoming investigations that we haven't even thought about yet. And so that's constantly going. Another one would be the nutrition study, where we're constantly analyzing and the crew are constantly logging what they're eating, and then we do a number of different studies and things that are related to what they eat. So we look at bone and muscle changes, changes in their vitamin status. And so that one seems to be ongoing. The third I can think of is the journals study. It's a behavioral study that's ongoing, and as you can imagine, over the last 10 years of space station, through the assembly phase, and as we change from the number of crew on board at any one time, and just the culture changes and the time changes over the time that we've seen a space station, the journal entries and the behavioral responses of the crew are important, and so those are being monitored and considered and applied to potential future use for human exploration beyond. low Earth orbit. So those, I think, are the three continuous. There's also a sleep study that's been ongoing for a while. Most of the continuous investigations that have been up on station for a while are human research based because we need so many humans involved in data collection. You need a solid sample size, and that takes time over a period of several years in some cases. So we see those ongoing, and they are also critical as things just change on orbit. The culture changes, the environment changes, the personality types changes, the crew complement size changes, and then we also need those human subject counts.
Okay, well, that's the end of our Twitter questions and our media questions here at Johnson Space Center and other NASA centers. I want to thank everybody for joining us for today's briefing. A reminder that we will be having the crew news conference coming up at 1 p.m. Central, 2 p.m. Eastern with Sunita Williams, Akihiko Hoshide, and Yuri Malenchenko. They'll discuss their mission. Of course, that's set to start with a launch on July the 15th on a Soyuz. And remember that all the latest information about the International Space Station is available. You can tune in through Twitter. We have the Twitter address that we can show to you on our screen here, at NASA Johnson, and @ Ask Station is the hashtag. We also have the International Space Station Facebook page. And of course, as always, the latest information, images, and video, including video wrap-ups from our daily updates, are available at www.nasa.gov/station. Thank you.